Hi, everybody, and welcome back for part two of the asset registers and control systems inventory, little mini series, if you will. The idea was to put this series together to talk about how asset registers, or really we're just talking about hardware and software inventory, works in control system environments. So previously we talked about it at a high level what an asset register is and its place in control system environments. So we wanted to talk about in the next section how we actually build those asset registers. And there's four different techniques or main ways that we can create a asset register. And we can look at which one of these might best suit our needs, or realistically, we might look at performing all four of them because realistically, that just performing one or a few might not give us 100% accurate asset register. We might still not get 100% accurate asset register by doing all four, but the idea would be at least we've put in the effort, we've gone through, and we've done as much as possible to make the asset register as complete as possible. So you can see the four different methods we have listed here. So one is walking the environment. So we can physically go through a plant or a site, tracing cables, probably starting with some network switches, or we can go out and find the different control systems and look at tracing cables throughout the environment. As you might imagine, not the quickest solution. It's definitely not the safest. So there's definitely some concerns. But a lot of people might think of this as the most accurate way to build a asset inventory. We can talk about review existing data. So when we talk about project file data or process data, we can look at the different network diagrams that exist for the plant. So we should have some engineering diagrams that would include the physical and logical layouts for the network. So we should be able to find assets and properties for those assets like IP addresses and vendor types, model numbers, the programming data. So if we have PLCs in an environment, we should have programming data for those PLCs. So all of those other different files can house pieces of information that we can use to bring together to build an asset register and think whether it's PLCs or something on a much larger scale like DCS that is aware of more than likely, the most, if not all, of the PLCs in your environment, then you can look at to the data there as well. We can talk about passive review of network traffic. And so we can look at reviewing things like packet captures to see if we can find different assets in the environment that we didn't already know about. So looking for things like IP addresses, but not just hosts that talk TCP/IP, but we can look at other hosts and industrial control assets that talk other protocols just besides TCP/IP. But we'll talk about those later on in their own section and what that process looks like. And then we can actively scan the environment, whether it's with a tool like Nmap or we go and purchase a ICS OT solution for active inventory management. And those tools usually do the packet, the passive capture as well. And so we can look at performing active scans. And we might see that in higher levels of the Purdue model when we're looking at the overall control system network as a whole, though we might not allow those at lower levels due to the concern that the active scanning might cause an issue with those more sensitive control systems and cause them to crash or completely brick where they would have to be replaced, which obviously then puts physical safety, environmental safety, and the operations of the plant at question. So what do we store in an asset register? So we've already talked real quickly about, well, how we're going to build the asset register. We're going to come back and talk about each of those steps. And that's really the main focus of the rest of this little mini series. But the idea is, so what do we store in the asset register? So you can see things like the asset ID and the name that we give it, right? Probably with some naming convention that means something to us as the organization, especially the folks that are doing the operations and maintenance. Of course, we would like to know what type of asset. Is it a PLC? Is it a laptop? What type of software, what type of operating systems are they running? Right? The manufacturer model. I'm definitely more concerned with those when we get into the tried and true control system assets like PLCs and DCS and HMI and RTU. We mentioned looking for things since they're connected to the network. So what about that? What are their IP addresses if they're running TCP/IP? Or again, what other type of addressing scheme might we have if there's other control system or other protocols in use in the environment? And then we can continue looking at the operating system version, firmware version, different types of software that's installed on the different types of the systems, right? How critical, how important that asset is to the environment, where we can see something like a safety instrumented system like SIS, which is the most critical in importance to the environment versus perhaps a engineering workstation where you might have 5 or 6 of those laying around on a shelf. So if you lost one, it's not going to impact physical and environmental safety. It's not going to impact the operations of the facility. And then we can also look at the very end, I mentioned the zones and conduits. So when we have a facility that's based off of ISA 62443, and we look at logically grouping assets together in zones, because we can control access to those zones a little bit more tighter than just using the Purdue model as our standard framework. So which zone does that asset reside in? And then between zones, we have the passive communication, which are the conduits. So which conduits also are these assets involved in? And it's great to be able to have that information as well in the asset register, because it helps us get a good understanding of the environment, and we can use that later on when we're having security conversations, especially when we're doing our risk assessments. And here's just a real quick sample. Right? And you can see this is very generic information, so I didn't put anything particular in here. I should have gone back maybe and put some real vendors and some real models, but I think everybody gets the idea that the asset register it's not rocket science. We're not putting any necessarily complicated information. We need to make sure we have the different pieces of information about the assets in the environment, so that way we can reference it when we do operations and maintenance within the facility. And we can, like we mentioned earlier, we can have this information available when we have our risk assessment conversations. And for me, a big focus from a cybersecurity perspective, whether it's in IT or now in ICS OT, right? When we talk about things like threat and vulnerability management, incident detection and response, and many other areas. But with just those alone, having an asset register is the foundation to allow us to do vulnerability management, incident detection, and response effectively in the environment. Without the information, we're grasping at straws in many ways. So asset registers are extremely important to the cybersecurity program of a ICS or OT environment, which is why I'm talking about it. So we mentioned the first way we can build an asset register is to walk the environment. We also mentioned it's the most physically dangerous, right? It's the least safe option that we have, because we do have people going out into the site, into the facility, finding assets, finding systems, and tracing cables. So they're not necessarily always going to be in the safest of environments, let alone potentially tracing cables through tight corners or dangerous environments. So we have to be very careful. So it's one consideration why we might not choose to walk the environment, even though, again, most people might consider this the most effective way to build an asset register, the most accurate way. It also takes the most time. As you can imagine, you have one or more people going out into the site, taking the time to look for those assets and trace the cables. It's a very time-consuming process, no doubt about it. And then what if somebody is tracing a cable and a cable accidentally gets disconnected or wiggled loose, and then we can cause production or availability issues within the site. Right? So there's definitely other risks as well at play. I do like the idea, though, if we do have somebody walking the environment, whether it's building an asset register or somebody doing maintenance, whenever they come across a PLC, one thing to keep in mind is to make sure we check to see that the PLC key switch is turned to run mode. Remember, with run mode, it means that the PLC is operating, it's running, it's doing its job, and that it can't be remotely updated, which means an attacker can't and come back and upload different code to it. It can't upload a new firmware, right? They can't update the program that's running on the PLC. So we want to make sure all of those PLCs are in run mode. So if you do have people out in the field, right, and in the site, and they come across PLCs, take the 2 seconds to locate the key switch and make sure it's running in run mode. That would be always the request, just to double check. Now, we also mentioned the second way is where we can look at existing data about the site to see or look for clues to build the asset register. It's very much, for me, sometimes it's like building a Sudoku puzzle. And so that you get just a few pieces of information, then we have to go back and fill in the blank. Like think of our Excel spreadsheet that we were just looking at. But you can look at, there's different types of data that we have associated with probably the more general term of project files. So you mentioned things like the network diagrams, logical and physical diagrams that we have from the engineering team that show us the actual design of the plan of the site. Any other designs that we have, any specs that have been provided by the engineering team. We mentioned different programming files that might have clues as to different assets that could be in the environment. We should have different asset specifications. Think even just from ordering, right? Receipts and invoices. We should be able to have some information or some idea of what's in the environment. Now, we talk about project plans and schedules could give us some additional clues, and change management. If we're going through a formal process to add new systems to the environment or decommission them, those should all be recorded. So we have that as an option. And then we can also look at the different configurations of you can see different network appliances we have in the environment. So think of things like network switches and firewalls. And then we can also go into those systems and look at different aspects of their running config. And then also we can look at things like their ARP table. The ARP table will give us a list of all the IP addresses and the associated MAC addresses with those IP addresses that switch or that firewall and the devices are aware of. So again, those are more clues that we have to be able to discover assets and then start filling in that asset register. Start filling in that puzzle to complete the picture. So here's an example of a very simple, right, high-level network diagram. I found quite a few interesting ones on the internet. I wish I could show you some of the more fascinating ones I get to see at the office. But here's a real simple one that came off the Cisco website. And so you can see, oh, I do see different assets highlighted. I do see IP addresses. I even start to see, oh, zones listed. And so we can start to take that information. Again, it's just those first initial clues to understand which assets are in the environment and then build out from there. Right? So network diagrams are a great place to start. And ideally, you can have those even in some of the older environments that we see. Usually there's some network diagrams running around somewhere. We talked about if you have different hardware appliances or network appliances in the environment, like switches and firewalls, you can go through the configuration. Like in this case, this is the configuration for a Cisco switch. So you can start to get names and IP addresses from that configuration, and all those little pieces that we can use to start building that asset register. Here's an example. If I'm sitting on that switch, that you can actually look at, again, the ARP cache that's on the switch. So all the IP addresses that switch has seen communication to or from with. And the MAC address is the physical address that's burned into the network interface of that asset, whatever asset is at that IP address, right? We have that MAC address. We can even see here that there's different VLAN interfaces. So we have the VLAN numbers, and that we can equate to, the different subnets that we see reflected in the IP addresses, because we see 192.168.80, then we see 192.168.10 and 192.168.6, and those more than likely were different subnets, and we can look at the labeling to see they're different subnets or they're different VLANs. But again, in this case, at least if we didn't know these assets existed, now we know there's 6 different assets in the environment. We have their IP addresses and we have their MAC addresses. We have an idea of the VLANs they're associated with. And then we can go from there, right, to find out more about, well, what are those assets. But we know they're there. We have the IP addresses, and we can even see based off of the ARP table that at least most of them have very recent communication. So they are there. And so we mentioned real quickly, I think it's worth having a conversation about ARP. So if we're looking at an ARP table, we understand what we're actually looking at. In TCP/IP, and we're just talking about TCP/IP environments, which is still going to be the most commonly used protocol that we have in any control system environment these days. That when two systems go to talk to each other, we always talk about connecting from IP address to IP address. But communication really happens at a much lower level when we talk about it really happens from the physical MAC address that's burned into the network interface on each system. So we're really talking MAC address to MAC address. But at a high level, we know we just have an IP address. Like when you go to ping an IP address to test that connectivity, you type in the IP address. But behind the scenes, your system has to resolve that IP address to that MAC address. And the MAC address is this 48-bit address. So there's 48 zeros and ones that represent the physical network interface of that system. And it's going to be unique from every other system on that network. So we can send traffic from machine to machine. Again, not just IP address to IP address, but MAC address to MAC address. And then one of the other things we can do to find hosts based off of ARP traffic is ARP is a broadcast protocol, which means if one computer is going to use ARP to find out what the MAC address of a certain system running a specific IP address is going to be, it actually sends out a broadcast, which means that packet goes to every computer on the network. And that the computers out there will return a response if it has the IP address that we're looking for. So if we're looking for 192.168.1.10, we send out a broadcast and say, hey, 192.168.1.10, are you out there? If you are, let me know what your MAC address is. Since we don't know what the MAC address is, we can't send directly to it. That's why we have to shout out to the entire network to see, hey, if you're out there, let me know. we can generate ARP traffic. This is what happens if you use Nmap to do a local scan of your local subnet that your system is connected to. Nmap actually realizes even if you tell Nmap to do a ping sweep to send out an ICMP packet to each system on the network to test for connectivity, it actually doesn't do that. It actually sends a ARP broadcast, which we can see here through the Wireshark capture. So Nmap realizes if you're trying to scan your local subnet that the laptop or the system that you're connected to that local subnet is on, if you're trying to scan the same subnet you're connected directly to, then it's much more quicker and efficient just to do an ARP broadcast. So that way, if there are hosts out there, they should respond back. And you can see here that this host is on the 10.2.1 network because it's saying, hey, 10.2.1.1, if you're out there, tell me. 10.2.1.2, if you're out there, tell me. 10.2.1.3, if you're out there, tell me. And you get the idea. And here, this case, we can also see because of the Wireshark capture and how it interprets and presents the information. We know, let's say in this case, I'm running Nmap from a laptop in the control system environment, and you can see that my IP address is 10.2.1.252. Right? We're saying, hey, if you're out there, tell me at this address, 10.2.1.252. So it's broadcast traffic, and that's actually reflected. You can see in the destination where it's. Remember, this is ARP traffic, so it's looking for MAC addresses to communicate with. I can see the source MAC address. That's the MAC address of my laptop. And then the destination is all Fs, which indicates it's broadcast. It goes to all computers. It equates to an IP address of 255.255.255.255. But that gives you an idea of ARP traffic. Most, I would say, control system environments consider ARP to be fairly safe. So it's one of those things that you can see in environments being used to quote unquote scan the network for host. It might not let you do any other type of active scanning activities, but you might be able to do the ARP broadcast. But that gives you an idea of what ARP looks like. And here's the Nmap command that I used to generate that. And so I just created that Nmap, in this case, the lowercase dash s dash n forces the ARP broadcast. And then you can see the results that come back. So then this is just on my local home network. So you can see it found 1, 2, 3, 4, 5 assets in the environment. 6. I can't count apparently. So it found 6 assets. And the really interesting thing, whether it's from an attacker perspective or helping us build our asset register, is that the MAC address, the first half, is actually tracked by the IEEE. So they have a database that tracks the manufacturers of specific MAC addresses. So you can take the first half of the MAC address and you can map it to an asset. Like if we look at the very last asset there, I look at the MAC address, I look at the first half, so I see AC4962. So the MAC address, it's 48-bit, so it's represented in hex. So 8C4962 is associated with the vendor of Roku. So it's one of the TVs. So that's one of the nice things when we're building an asset register. If we have the latest and greatest updated MAC address database from IEEE, it could also tell us what type of asset is there so we know, or at least we have a good idea of what we're looking for. In that case, yeah, I'm looking for a TV, but what if I see something like Siemens or Rockwell Automation, Allen Bradley, Schneider Electric? Then I might be looking for things like PLCs. So a couple of things to think about. We can also go into the ARP tables on other systems in the environment, not just the network appliances. But you see on Windows machines, you can type ARP-A to look at the local ARP cache pretty much I think what you're typically looking for are all those that are labeled dynamic. You can see at the top, because all the others are built in. Those are really for networking configurations to allow networking to take place. So things like broadcast, which we mentioned, remember all Fs, and then the others we see things like multicasting addresses. So those aren't going to help us find assets, but those individual IP addresses that we see at the top of the list will. And then on Linux, if you have some Linux hosts in the environment, which you might as well, you can just run ARP, or there's a ARP file that you can read. So the cat process allows you to read that file, which is stored in /proc/net/ARP. So if you're not familiar with Linux, it just means there's a file called ARP in a folder called net, which is in a folder called proc, essentially. And that brings us to the end. So I appreciate everybody for jumping into part 2 of the series. And in the next part, we're going to come back and we're going to dive deeper into the passive, if you want, passive scanning, but I hate that term, and we'll talk about that in the next section. We'll be looking at really what packet captures, and using Wireshark and other tools like Network Miner, but primarily Wireshark, to find what assets are in the environment based off of captured network traffic, and then look at the different potentially types of assets and the different services and applications that are running in the environment as well. So thanks for taking the time to watch the video. I really appreciate it. And if you have any questions, comments, concerns anytime, feel free to reach out. You can get me at the email address below, find me on LinkedIn. You're obviously here at YouTube, and reach out or leave a comment in the video. All right, I appreciate it. Thank you again.